Okay, here we have the final exercise of this chapter and quite a difficult challenge. Okay, so with something like this where you can't initially see the endpoint, always start off by drawing what you can. Okay, vectors are very visual. Draw a diagram, you might get some marks for it, also might help you get to the final answer. Okay, so let's start off with this straight line. Let's rewrite this as y equals 5 minus 5/3 x. Okay, now I'm going to set x to 0 when x is 0, then y is 5. Okay, so this is one of our points. Then our other point is when y is 0, we're going to have x. So let's explicitly say that. Okay, x is going to be 3, right? Because if you sub in this to be 3, you get 5, take away 5. Okay, so x is going to be 3. And then this checks with our negative gradient that we need. Okay, so this straight line is y equals 5 minus 5/3 x. Okay, now, given that the magnitude of O to B, okay, B is some point on this line. All right, the magnitude of O to B, I think it's always helpful to figure out what this is as an actual number. Okay, so I'm going to put that in my calculator. Square root of 34 over 2. Okay, and it's going to be 2.915. Okay, so we have an estimate of how kind of big this is going to be. So this point B, okay, or the two possible point B's, going to have to be inside this triangle here, okay, on the line inside here, okay, because anything outside is going to be bigger than 2.9 as a distance. Okay, so let's label this our origin. These are our two possible point B's. Okay, so we need to find possible expressions for OB, two possible expressions, okay, in the form of R, I's, and J's. Okay, so we've got O to B. Let's draw out that vector. O to B, O to B. Okay, and we know that length is square root of 34 over 2, square root of 34 over 2. Okay, now what you can see here is I've drawn two triangles. Okay, this B coordinate is kind of our x1, y1, B coordinate is going to be x2, y2. And this length is going to be, see, x1 here, x2 there, y2 there, y1 there. All right, so hopefully you're looking at that and you're thinking Pythagoras theorem. Okay, so our x squared plus our y squared for our b coordinate is going to equal our c squared. Okay, c squared in this case is square root of 34 over 2 squared, so 34 over 4, which is 17 over 2. Okay, so we've got this equation, x and y. We've also got another equation in terms of x and y. Okay, and now that we got to this point, you should have alarm bells ringing in your head. We can solve this simultaneously and get to our final answer. Okay, so this is a challenge part of the question. Okay, this is a difficult bit, getting to this point. The next bit, you're going to just watch me struggle through some simultaneous equations. Okay, so I'll tell you the final answer. So if you don't want to see me struggle through the whole part, actually no, I won't. You can watch me struggle, or you can just kind of skip ahead. So x squared plus, and then 5 minus 5/3 x squared equals 17 over 2. Okay, we just subbed in y into here, and let's go x squared plus 25 minus 25 x plus 25 x plus 25 x squared equals 2. Fine. 34 over 9 x squared minus 50 plus 32. Okay, now thank God we've got our good calculators that can solve this for me. Okay, so we're gonna solve this polynomial, agreed to polynomial, 34 over 9 minus 50 25. Okay, so x1 equals 99 over 34, x2 equals 3 over 2. Again, when you get nice x's like that, it's kind of hard to argue that you would be right. Okay, perfect. Now we need to figure out what our y's would then be. So using x1, we have 5 take away 5 over 3, lots of 99 over 34, which gives us our y1 equals 5 over 34, and then our y2 is going to equal 5 to 5 over 3, so 3 over 2, which equals 5 over 2. Okay, and that there is our final answer. Okay, and we can now need to put it in I and J form is the question asked for. Okay, so B1, I guess, or vector B1 would be 99 over 34 I plus 5 over 34 J, and then B2 would be 3 over 2 I plus 5 over 2 J. And that